Our planetary neighbour, Mars, is a cold, barren rock. Its rusted surface covered in parched sand. But beneath the dust, the planet bears the scars of a former life. Billions of years ago, Mars was just like Earth. A world with a thick atmosphere that supported oceans of water. But today, that world is gone. Mars lies dead, while the Earth thrives. Why the two planets had such different fates is a mystery that we've only just begun to answer. You see that pale red point of light in the sky, just there? That's Mars. Through a small telescope, it appears almost Earth-like, our sister world, polar ice caps, and dark surface markings that 19th century astronomers thought were vegetation, even canals bringing meltwater down from the poles to arid equatorial cities. Across the depths of space, the inhabitants watched us with envious eyes, wrote H.G. Wells. We now know that there are no eyes looking back at us. Mars is a frozen, arid desert world. But the fleet of spacecraft have revealed that it hasn't always been that way. During its brief flyby, Mariner 4 gave us our first close-up glimpses of Mars. From orbit, Mariner 9 photographed 80% of the Martian surface.
First of all, there are two eyes, not only in color, but also in stereo and in the infrared part of the spectrum. It has a sense of touch. It has a sense of hearing. But by far the most important feature of the lander is its brain.
The Viking program took us down to the ground for the first time and revealed Mars like never before. The data gathered over the last 50 years has allowed us to create detailed maps of the Martian surface and to begin to piece together its past. Maps of Mars are like storybooks. You can read the history of the planet written across its surface. And the reason for that is that there's virtually no erosion. It hasn't been for billions of years. So the scars of events that happened even 4 billion years ago can still be seen. This is a type of map called an elevation map. The colours correspond to difference in heights on the surface. So blue means low, and red and white are high. Now this region here, which is much higher on average than the rest of Mars, is called Tharsis, and it's covered in volcanoes, including the largest volcano in the solar system, Olympus Mons. At the other side of Tharsis is the Great Vallis Marinaris, the Mariner Valley, and it is a canyon that dwarfs anything we see on Earth. On the opposite side of the planet is an impact basin called Hellas. The height difference from the crater rim to the crater floor is 9 kilometres. That means you could fit Everest in the middle of there and look down on its summit. And the region surrounding the basin reveals Mars's former life. The Hellas Basin is punched into the oldest surviving terrain on Mars. It's called Noachis Terra, or the land of Noah. And that's a wonderfully evocative name because its surface is sculpted by flowing water. All across the earliest Martian surface, we've glimpsed traces of what appear to have been lakes and rivers. And so a new generation of spacecraft has been sent to Mars to investigate the existence of water. And what happened to the planet for it all to disappear? Led by the most audacious Mars mission ever attempted, to land a 1-ton rover on the Martian surface. Its final descent has become known as the 7 Minutes of Terror. Curiosity touched down in Gale Crater, a 150-kilometre wide impact basin thought to have been home to an ancient lake. The rover is a $2.5 billion mobile chemistry lab designed to take samples of the Martian surface and analyse its composition. As it explored the crater, Curiosity saw pebbles polished and rounded by running water in what had once been rivers and streams. Then, 61 days after landing, Curiosity identified the perfect spot to begin its primary mission. In a sandy area of the crater called the Rock Nest, the rover took its first scoops of Martian soil. Chemical analysis of the fine, dusty sand revealed something quite unexpected. Even though the surface of Mars appears completely dry, 2% of the soil is still made up of water. Curiosity had found evidence of just how wet a planet ancient Mars had been. For hundreds of millions of years, Mars was a water world. Rains fell, rivers ran, and in the northern hemisphere, water collected in a vast sea that covered 1/5 of the Martian surface. The red planet was once blue. All the evidence suggests that there were large bodies of standing water on Mars around 4 billion years ago. And the atmospheric pressure was at least that of Earth today, perhaps even higher. Temperatures were around 25 degrees. So I could have sat on Mars all those years ago, admittedly with a mask to breathe because there was very little oxygen, but I could have sat there and looked out over a view like that. So you don't have to imagine what Mars was like in the past. You can experience it. It was pretty much like this. But within 1 billion years, all Mars's lakes and seas had disappeared. In our solar system, only one blue planet survives. Mars's sister, Earth. 70% of our planet's surface is covered by ocean. Under the waves, 1 million species thrive. While on land, the rains support Earth's delicate ecosystems, providing a home for an abundance of life. But it hasn't always been this way. The early Earth was unrecognizable from the planet we know today. Its atmosphere thick with carbon dioxide. And its oceans acidic 4 billion years ago, Earth was a troubled, toxic world. While Mars was flourishing. But both planets were about to be engulfed by a cataclysm from space. To understand what happened, we have to look beyond our own world. You can't read the deep history of the Earth by looking at its surface, because our planet is a geologically active world. The surface is constantly being reshaped by volcanic activity, weathering, and the actions of the oceans. But we have a companion, the Moon, which has been inactive for many billions of years. And so the history of events that happened in this region of the solar system is written all over its surface. The most distinctive feature of the Moon's surface are its craters. It is literally covered in a record of impacts from space, and that allows us to estimate the relative ages of different parts of the Moon. And quite simply, if there are more craters, then that piece of the Moon must be older. There's been more time for the impacts to build up. But we can do better than just measure the relative ages, because we have rocks. The moon rocks brought back by the Apollo astronauts. Now we can estimate the ages of rocks very precisely by looking at the rates of decay of radioactive elements inside them. They're like little stopwatches that start ticking the moment the rocks are formed, in this case by the impacts from space. So the moon rocks allow us to tie the number of craters in a particular region of the Moon to an absolute age measured by the rocks. And this doesn't just allow us to date impacts on the lunar surface. It means that craters can be used to read the histories of worlds across the solar system. Including Mars. When we gathered all the data, we discovered something surprising. There was a peak in the crater formation rate about 3.8 to 3.9 billion years ago, which signified a period of intense violence in the solar system. And that is called the Late Heavy Bombardment. Countless asteroids fragmented in Mars's atmosphere, raining havoc across the planet. It's estimated that 53 tons of rock fell on every square metre of Mars. Over a third of the planet's surface was obliterated. And Mars was pushed to the brink of death. Whilst the evidence from the surface of the Moon tells us that the late heavy bombardment happened, it doesn't tell us why. For that, we have to resort to computer models of the evolution of the solar system. And when we do that, they point the finger at Neptune. It's thought that Neptune migrated outwards into the Kuiper Belt, a region of icy rocky objects orbiting at the edge of the solar system. The resulting gravitational interactions disrupted those orbits and sent many of the objects inwards to the inner solar system, and that may have been the cause of the late heavy bombardment. Earth also suffered the onslaught. And for tens of millions of years, the fortunes of the two sister worlds hung in the balance. But just when conditions appeared at their least promising, Earth's most precious characteristic emerged. Life. It's thought that in warm volcanic pools or deep-sea hydrothermal vents, conditions were right for the chemical building blocks of life to form spontaneously. And that means that if similar conditions were to be found elsewhere in the solar system, it might be possible that life began there too. So in 2005, NASA embarked on a mission to look for those same environments on Mars. For more than a decade, the Mars Reconnaissance Orbiter has been our eyes on the red planet. Sending back more data than all the other Mars missions combined. MRO has made more than 60,000 orbits, mapping over 99% of the planet's surface. Its high-resolution cameras have revealed Mars as never before, discovering polar avalanches, shifting sand dunes, and what could be seasonal flows of sand or even liquid meltwater. Then, in 2017, MRO turned its gaze to one of the red planet's oldest features, the Eridania Basin. 3.8 billion years ago, the basin was a vast sea, holding 10 times more water than the Great Lakes of North America. And it was here that MRO found the evidence it was looking for. 400-metre-thick deposits of minerals that, on Earth, form in deep-sea hydrothermal vents. In the Eridania Basin, MRO revealed that conditions on Mars had once been ripe for the emergence of life. The habitable conditions during what's known as Mars's Noachian era persisted for hundreds of millions of years. But then, prospects for life on the red planet changed dramatically. As molten rock pushed upwards through the crust, meltwater poured out onto the surface. It raged down from the southern highlands, until, in a place known as Ecus Chasma, it plunged over cliffs 4 kilometres high. Once the flood subsided, the water disappeared, leaving the evidence of the falls etched into the face of the planet. Deep within Mars's core, something was causing the planet to die. And the evidence can be found in Mars's atmosphere. In September 2014, NASA's MAVEN probe made its final approach to the red planet. Its mission? To understand what drove the planet's dramatic climate change. MAVEN is equipped with an array of instruments designed to measure the behaviour of the atoms and molecules in Mars's atmosphere. The spacecraft circles Mars in an elliptical orbit. Allowing it to measure the full profile of the planet's upper atmosphere. At its lowest point, it's just 150 kilometres above the surface. At its highest, a little over 6,000 kilometres. And it was at the very top of Mars's atmosphere that MAVEN found the key to the mystery of what happened to Mars. Detailed measurements revealed gas is being lost from the Martian atmosphere, escaping to space at a rate of about 2 kilograms every second. Over time, it's thought this gradual stripping away of Mars's atmosphere has slowly thinned the insulating layer surrounding the planet, causing surface temperatures to plummet. But what was it that caused Mars to lose its atmosphere, while Earth clung on to hers? "150 million kilometres away in that direction is the setting sun, a giant nuclear fusion reactor. It's got 1 million Earths inside it. Now the surface temperature is only around 6,000 degrees Celsius, but the sun's atmosphere, known as its corona, is at 1 million degrees. And that means it's in the form of what's known as a plasma, a soup of electrically charged particles. And some of those particles are moving around so fast that they can escape, and they stream away in what's known as the solar wind. They reach the Earth travelling at a few hundred kilometres per second, and if we weren't protected, they would strip away our atmosphere. And when the sun dips below the horizon, there are times when that protective force field is revealed. You just look at that. I mean, there is the aurora. It's the laws of nature, all of them, written across the sky. Electrically charged particles have been driven away from the sun, ultimately from nuclear fusion reactions in the core of a star. They're crossing the solar system, hitting the Earth's magnetic field, stretching it out on the dark side of the planet. The field then just snaps back like an elastic band, accelerating all those charged particles up and down the field lines to the poles, which is here in the skies over Iceland. And they hit nitrogen and oxygen molecules in the atmosphere. And you're seeing quantum mechanics. They're exciting the molecules so that they emit light in characteristic colours. And if you think about it, this is the only time that we really see the Earth's magnetic field. As one of the reasons why life on Earth has been able to persist for 4 billion years. In a sense, that's the reason that you exist. It's Earth's magnetic field that protects our atmosphere from the ravages of the solar wind. And that protective shield has its origins deep in the planet's interior. Thousands of kilometres down below my feet, actually below your feet now, is the Earth's outer core, which is a seething mass of molten iron. Convection currents cause the molten iron to rise, and then the Earth's rotation causes it to spiral around. Now, a spiralling, circling flow of an electrically conducting liquid is a dynamo. The dynamo generates a magnetic field, and the Earth's field rises up not just to the surface here, but out into space, forming our protective shield. And that, what you see there. And just like Earth, ancient Mars was also shielded from the sun. Aurora once danced above its poles, keeping guard over the Martian atmosphere and seas below. But between 3.5 and 4 billion years ago, Mars's dynamo switched off. The aurora surrounding the poles slowly faded away as the magnetic field diminished, allowing the atmosphere to be stripped away by the solar wind. Without protection, the seas evaporated, the surface froze, and Mars was transformed. At the same time, the fortunes of Mars's sister world were about to take a very different turn. For the next billion years or so, Earth was indistinguishable from the landscapes of early Mars, barren continents surrounded by ocean. But in Earth's oceans, life was beginning to transform the planet. Primitive algae started to neutralise the ocean's acidity and replace the dense red fog of Earth's methane-rich atmosphere with oxygen. Around 600 million years ago, that oxygen-rich atmosphere allowed complex life to evolve in the oceans, colonise the land, and ultimately produce this almost infinitely rich living world today, of which we are a part. While Mars died, Earth flourished. To understand why the two sisters had such different destinies, you have to go right back to the time the planets were forming. When Mars and Earth were born, the solar system was a chaotic vortex of gas and rock. Material clumped together and grew, only to be smashed apart. But there was one crucial difference between the young planets. Mars formed in a region of the solar system with considerably less rocky material, and that had a profound impact on the planet's growth. Mars is a significantly smaller world. It's about half the diameter of the Earth, and that makes all the difference. Although the details are not yet fully understood, it seems clear that Mars's smaller size meant that its dynamo switched off many billions of years ago. Being smaller meant Mars's core cooled more quickly than Earth's. And this is certainly part of the reason why Mars lost its magnetic field. Even though the planet is further away from the Sun than we are, that meant that the solar wind stripped away its atmosphere and Mars died. So, even though Earth and Mars are so similar in so many ways, the difference in position and size in the solar system led to very different fates. Long ago, two sister worlds were born. In childhood, Mars was warm and wet. Whilst the Earth was inhospitable and toxic. Both young planets survived the violence of the late heavy bombardment, emerging as mature worlds, primed with all the ingredients for life. But deep inside, the smaller of the two was dying. Mars's seas dried up. And as the planet's interior cooled, one by one, her fires went out. Olympus Mons, the largest volcano in the solar system, last erupted around 25 million years ago. As the lava turned to stone, Mars was frozen in time. And so, today, her surface lies rusted and gathering dust. But that might not be the end of Mars's story. Mars is, in a sense, a failed world, a faded ember etched with the memories of a more enticing past. But there may have been, and may still be, life on Mars. And the discovery of the second Genesis in our solar system would have profound philosophical, scientific and cultural consequences, because it would mean there is a sense of inevitability about the origin of life. And that would mean that the universe is most likely teeming with life, that we are not alone. Equally importantly, I think, is the role that a planet with a history like Mars could play in our future. Mars is rich in resources. It has vast reservoirs of frozen water below the surface, and minerals, iron, nitrogen, carbon, oxygen, all the things you need to support civilization. And that's why I think that in my lifetime there will be Martians, but the Martians will be us. We will go to Mars and make it our home, and that old red world will become our first step beyond the cradle and out to the stars.